All right, we begin a new unit here today, and so in this first section, 10-1, we're talking about parametric equations. And so let's start by taking a look at what parametric equations are. So we have, if f and g are continuous functions of t on an interval I, then the set of ordered pairs f of t comma g of t is a plane curve C. And these equations, x equals f of t and y equals g of t, are the parametric equations for that curve. And then t is called its parameter. All right, so when we're talking about parametric equations, right, then you've got these two equations, x and y, in terms of some other variable, in this case t, right, where it's still graphed on a two-dimensional plane, right, but there are three variables involved, the x, the y, and the t. And the x and the y are both written in terms of t, and t is called the parameter. All right? And so this is just a set of parametric equations, is another way to write an equation in a two-dimensional plane that's typically expressed by just y in terms of x, all right, one in terms of another. So instead of x and y being written in terms of each other, they're written in terms of a third variable, t, which is called the parameter. All right, and that allows us to do a couple of different things. All right, let's just do an example of one so you can kind of get the hang of what parametric equations are. All right, so first of all, I have two equations. Are they parametric equations? Yes, because the x and the y are both written in terms of t, that third variable. Okay. Now, here's my interval for t, -2 to 3. Okay. So one thing that helps is us to actually plot a set of parametric equations and kind of see what we come up with here. So if we want to sketch the curve, then what we can do is we can plot the points on t from -2 to 3 over that interval, right? Now, remember, this variable t is not one of the two axes on the graph, right? So we can't go to -2 or whatever by looking at the axis and counting it off, because there is no t-axis. You see what I mean? Okay. But what we do instead is we take the value, the starting value at -2, plug it into each one of the equations, and that gives us the x and y to plot the point. So if I plug in -2 here, that's going to be 4. 4 minus 4, the x is 0. But at that same point, -2 divided by 2 is -1. So at t -2, the point on the graph is 0, -1, and it's plotted over here in this figure. 0, -1 at t -2, there's the point. So again, by picking values of t in the interval and plugging them into the x and y equation, you can get the x-coordinate and the y-coordinate in order to plot it on the graph. Okay, and likewise, at t equals -1, it yields this -3, -1/2. Right, so that's the point. And then at t0, it's -4 and 0, right? And then same thing for t1, 2, and 3. And then you've got all your points plotted on here, right? So that is the curve, right, yielded by these parametric equations, right? So again, we use the values of t in the interval and put those in the parametric equations to yield points, right? And those are the points that are showed in the table, and then you plug it in, and then there it is. Okay, so by plotting these points in the order of increasing t, you get the curve, and then the arrows on the curve indicate the orientation as t increases along the interval, so that when a particle moves along this curve, it would start here at the initial point and then move along the curve until you get to this ending point along the interval. Okay, so what's the advantage of writing these as a parametric equation instead of just a regular equation in terms of two variables? Because you could still generate an equation over a certain interval, right, that would still give you this same curve. So what's the advantage of having it in parametric form? Well, that third variable does a couple of things for you. Number one, that third variable gives you direction, to whereas it's written in terms of x and y, you don't necessarily have direction. That's the first thing. And the second thing it does is it gives you specific points over that third variable, which could represent different things, time, etc. Right? So in other words, you can talk about, okay, where is the curve after, at -1, at 0, at 1, and so on. And those are independent values of that third variable, and it's not tied to any axis. So when I say, well, so where's the curve? What's the value when, or where's the curve at when t is equal to 2? Well, t is equal to 2. You can't find that and count it on the axis because the axis are in terms of x and y. Okay. So again, it kind of gives us a third variable in order to express that can kind of represent different things. All right. So again, the advantage is you get direction and you get a third variable that can represent something different, like over time, for example, right, as the curve is being drawn out over time. Okay? So what are we going to do now with parametrics in this particular section? Well, what we're going to do is we're going to learn a technique called eliminating the parameter. So what that allows us to do is to take a set of parametric equations and write it back in what is called rectangular form, which is just in terms of x and y, right? So we can eliminate the parameter. In other words, eliminate the third variable and get that same equation back. Okay, so many curves that are represented by parametric equations have graphs that can also be represented by rectangular equations, right? So in terms of x and y. So instead of the third variable, you only have 2 like we normally deal with. Okay. The process of finding the rectangular equation is called eliminating the parameter. So what are the steps? You start with the parametric equations, solve for t in one of the equations. So this one's solved for t in the y equation. Substitute that back into the second equation and then simplify down, and you've got the rectangular equation that matches that set of parametric equations. All right. So let's do a couple of examples here. So let's say I wanted to eliminate the parameter in this one. So I want to take these two parametric equations and just write them as one single rectangular equation. All right. So remember, with parametric equations, you've always got to have 2 in terms of a third variable. But if I take it and turn it back to rectangular form, or just a normal equation written in terms of those 2 variables, then here's the procedure. So what we can do is we can take this one now and solve it for t, right? Take the x equation and solve it for t. And so now when I do that, what I can do is, first thing I can do is square both sides. So that'll give me x, that'll give me x squared is equal to 1 times 1, there's 1. But square root of x plus 1 times the square root, or excuse me, square root of t plus 1 times the square root of t plus 1 is just t plus 1, right? And then from here now, what we can do is we can just take the reciprocal of both sides. So that would be 1 over x squared is equal to t plus 1. All right. Then from there, we can go t is equal to 1 over x squared and minus 1. So now we have taken that and solved it for t. And now I'm going to take this and substitute it in for t into that second equation, the y equation. So when I do that, it's going to look like this. Y equals, so in place of t, here's now what I'm going to have. 1 over x squared minus 1. And all of this is now going to be over. I have another t here in that equation, so that's going to be over 1 over x squared minus 1 plus 1. All right. So all I've done here is I've just taken the substituted this for t in that equation. So that's y equals all this. All right. So now I can go in and start kind of simplifying this thing a little bit. So let's work with the top. All right. So on top, what I can do here is I can change this 1 into a common denominator of x squared. So this will be 1 over x squared minus x squared over x squared, which actually is 1. And on the bottom, we can do negative 1 plus 1. That's gone, so that's over 1 over x squared. All right, so now I can combine these together now that they have like terms, and when I do, we're going to have this. So when I combine that together, then that's going to be 1 minus x squared over x squared. All right, and then now that's over 1 over x squared. And of course, to simplify that down, fraction divided by a fraction, you can just multiply by the reciprocal. So we'll go 1 minus x squared over x squared times x squared over 1. And then finishing that up, the x squared will cancel here, and that becomes 1 minus x squared over 1, which is 1 minus x squared. So now we've taken these parametric equations and then we've turned them into rectangular form, or just the regular form that we are typically used to dealing with, y in terms of x. Okay, so this set of equations and this equation will yield the same graph. What's the difference? When I have it in this form, I have it in terms of a third variable. Then I can talk about direction, and then I can also talk about where the curve is at a certain time for t, at a certain value of t. Whereas when I have it in this form, I cannot talk about those things, right? Because the parameter is eliminated, right? And so that's the step. So now I've taken it from parametric form back to rectangular or just regular form. All right? Eliminate the parameter. Eliminate that third variable. And as you can see, a lot of this, sometimes it can get kind of algebra-y, right? So most of our work was spent trying to just kind of simplify all these fractions over fractions down, right? So it can get a little messy in that regard. All right, what about the next one, though? We want to write this one in rectangular form. So it's parametric because I have x and y in terms of t, the third variable. So once again, I'm going to take this x equation and write it, solve it for t. So when I do that, I can just divide both sides. Well, really, I can just go straight at it if I multiply both sides times 1/3, right? Or negative 1/3, I should say. So that becomes t equals negative 1/3 x. So now it's solved for t. So now I can take this now t and shove it into the other equation, and we got y equals, open, negative 1/3 x, close, squared, plus 2. All right, and simplifying down really in just one more step, y equals, square this, negative and negative is a positive, 1/3 times 1/3 is 1/9. Then that'll be x squared and plus 2. And you've got it. So all we're doing really in this section is rewriting parametric equations into rectangular form.